Communicating with air traffic control is an integral part of operating at large airports and in busy airspace. Let's dive deeper into the ATC system to look at the various services offered and the specific procedures for flying into and out of tower-controlled airports.
All air traffic control radar facilities provide, on a workload permitting basis, traffic advisories and limited vectoring to VFR aircraft. To receive this service, the aircraft has to be able to communicate with the facility, be within radar coverage, and be radar identified. Factors such as limitations of radar, frequency congestion, volume of traffic, and controller workload could prevent the ATC controller from providing radar traffic advisories. The controller has complete discretion, and the controller's decision not to provide radar assistance is not subject to question. It should also be pointed out that not all towers and associated approach and departure controls are equipped with radar. Radar assistance and traffic information does not relieve the pilot of the responsibility to see and avoid other air traffic. You should also understand that radar vectors are advisory in nature and do not authorize the pilot to violate federal aviation regulations. In most cases, the controller is unable to determine if the radar vectors will take the aircraft into instrument conditions. After establishing contact, the departure controller will give you radar traffic advisories. Other aircraft will be described in terms of clock position, distance, direction of flight, type of aircraft, and altitude if known. Clock positions are given in relation to the track of your aircraft. Remember, the controller cannot see the heading, but does see the track of your airplane. 12 o'clock is the direction of your track, with the clock positions 30 degrees apart. If you're holding a 20-degree right wind correction angle, traffic that ATC reports at 2 o'clock would really be 40 degrees to the right of the nose of your airplane. Air route traffic control centers, called centers, handle en route IFR traffic in controlled airspace. Recall that there is no control of air traffic in Class G airspace. When controller workload permits, advisories and assistance may be provided to VFR aircraft. There are 20 centers in the conterminous 48 states. Each center has jurisdiction of controlled airspace the size of several states. Each center controls IFR traffic within its own area and coordinates with adjacent centers for the orderly flow of IFR traffic between areas. Centers are divided into sectors. Each sector controller handles IFR traffic within the sector and coordinates with the controllers responsible for adjacent sectors. Radar and automation make it possible for the system to handle the tremendous volume of air traffic.
The controller's display can show a wide variety of features, including airport location, runway final approach course, and special use airspace. It can also show a weather radar overlay to help controllers vector aircraft around heavy precipitation and thunderstorms, as shown in the example here. Light rain is represented by dark blue shading, while the concentration of dots and brown shading depict areas of heavier rain and precipitation. The display also tags each airplane with unique information about the flight. The data tag includes aircraft identification, altitude, ground speed, destination airport, and aircraft type. The system will show a red LA symbol above a traffic target to alert the controller when an airplane is flying at a low altitude in a particular sector.
All of the higher altitude airspace in the lower 48 states is covered by radar. Low altitudes, which are distant from a radar site, may not be in radar coverage. You may hear the controller also tell you to ident. The proper response to this instruction is to activate the ident feature of your transponder after entering the assigned code. This is simply a way of enhancing your radar identification for the controller. When entering transponder codes, there are certain number combinations that should be avoided. Some squawk codes have been assigned for use during special circumstances. For instance, 7700 is for emergencies. 7600 is for communications failures, and 7500 indicates to the controller that you have been hijacked. Code 7777 is used for military interceptor operations, something that most pilots would find disconcerting to say the least. These codes, plus all codes starting with 76 or 77, cause priority displays on the controller's screen. The controller will assume you have a problem if you inadvertently enter one of these codes or even pass through it while dialing in a correct code. Procedures for using these codes are spelled out in the Aeronautical Information Manual.
For instance, in the event of a communications failure, which is not considered an emergency situation, set your squawk code to 7600. This will show up as RF at the top of your radar data block on ATC's radar screen, which stands for radio failure. However, don't assume that a controller sees this because you might not be in radar coverage at the time.